This is how you can make a falling hexagon level similar to ones in Stumble Guys and Fall Guys using Unreal Engine in only 10 minutes. First, you need to open up Unreal Engine. I'm using version 5.5, but any version works. When the engine launches, just open a basic third-person world. This is just going to simplify the player character and the world so we can get started on the gameplay quickly. After a few minutes of loading, you can see the basic level. We can start by getting rid of stuff we don't need, so remove this text and all the boxes and ramps since we won't be using them. Also, it can be good practice to remove the player start component here in the world and just add a new one. Quickly just place this down in the world and give it a test. As you can see, we don't have to change much about the character. He can walk around and jump. Alright, now that that's done, we need to make our hexagon. If you look in shapes, you will notice we aren't given one. Go into modeling mode and select cylinder. To make this cylinder into a hexagon, we need to reduce the height. Here I'm going to change it to about 20. And change the radial slices to 6 as a hexagon has 6 sides. I'm also going to adjust the radius to make the hexagon big enough to walk on. Okay, once you're done, click accept. And in the details panel, you can click this button and it brings you to the folder location of the mesh. I'm just going to copy this over to my own folder so I know where it is. Now that we've made the hexagon, we want to be able to add some logic to it so that things can happen when we walk over it. For this, we need to make an actor. I'm just going to call mine cylinder actor, but you can call it whatever's. Currently the actor is empty. Click add component and then add a static mesh. We can just drag and drop our model from the content browser into the static mesh slot. By dragging this actor into the level, now we can see a programmable version of the hexagon that we just made. Let's quickly set up a level using the hexagon. Here I'm just copying and pasting and then using the arrows to shift the location. You can also alter the numbers on the right to change the actor's location and rotation in the world. Select all of the actors in the outliner and move them to a new folder for organization. This isn't necessary, but it's good practice. Now that everything is in a folder, I can go ahead and right click to select all of the actors in the folder and then just copy paste to make a new layer. You can see that the above layer has cast a shadow on the lower layer, so to avoid this I'm going to quickly add a point light into the world. I'm just changing the intensity and radius to make it look a bit better. Now I'm just going to go ahead and repeat that process once more to make a third layer to the level. This last layer is a bit too high, so I'm just going to make sure that it's got the same height difference. Let's go back into our cylinder actor, because now we can make a way to detect when the player walks on the object. Usually you would use a collision component like a box or sphere collision like this, but it's not going to be as precise as we want since our shape is a hexagon, so we'll use something else. Let's copy our previous hexagon and set this second one to be hidden in game. This means that the player won't be able to see it. I'm just going to stretch it to make sure that the player is detected when it runs through this box. Currently, even though the box is invisible, the player still won't be able to run through it. So we need to change the collision preset of this detection hexagon from block all dynamic, meaning that it blocks the player, to overlap all. This means that anything can walk over it and it detects when this happens. I don't want the player to be detected unless they're walking over the hexagon, so let's shrink the collision hexagon a bit so it's a bit fair on the player. To program some logic into this overlapping hexagon, let's scroll down in the details panel and click the plus next to on begin overlap. This allows us to do something when the player overlaps with the hexagon. Dragging from this node, let's check that the other actor, which is detected by the box, is the player and not anything else. We need to do something if this condition is true, so let's add an if node. Now we need something to happen when the player is walking over the hexagon, so let's change the color of the hexagon to red. To do this, right click in the content browser and make a new material. We can just change the base color to red like this. Then click apply and save. Now we have our color. From the condition being true, search set material. And here, the material of static mesh needs to change, as this is the hexagon that the player sees. Static mesh 1 is the detection hexagon. Change the material to the new material that we just made, and then compile to check for errors and save the progress. I'm also going to make a new color for the hexagon, as gray is a bit bland. So let's duplicate our red color and just change this color to a bit more yellow. In our hexagon actor, change the material to the yellow color. As you can see, it looks a lot better, and when the hexagons are walked over, they turn red. After testing, I think the detect boxes may be a bit too quick to detect the player, so I'm just going to make them a bit smaller. Now it feels a bit better. However, the hexagons that the player jumps over still turn red, so let's quickly change this by shortening the detection box. Just to make it feel a bit better, I'm going to add a quick delay before the hexagon turns red after detecting the player. And after a bit longer, I want the entire actor to be destroyed so that the player can fall through. Let's quickly move the player start up here so we can give it a test. As you can see, now the tiles get destroyed after the player walks on them, and you can fall down to the level below. Let's quickly add a small animation where the tile shrinks instead of just disappearing. To do this, drag out the static mesh component, which is the visible hexagon, drag from the point here and search set world scale 3D. Instead of just setting the scale, we want the size to decrease over time, so right click anywhere and search add timeline. This will allow you to change the value over time. You can name this anything you want and double click it. After double clicking, it might seem like a lot, but essentially we need to add a track, because this allows us to make a curve representing the different scale values over time. Right click on the graph to add a key. Essentially this is just a point on the graph. We want to first begin at a scale of 1 at time 0, so change the value to 1 and time to 0. Then we want to make a new point where at time 1, aka after 1 second, the scale of the object is 0. Going back to our event graph, which is where we were programming previously, every millisecond we want to change the scale to the new point on the line. To do this, we need to split the scale up to its x, y, and z values, and we need to connect the x and y value to the decreasing value from our timeline. Next, you need to connect the set scale node to the update. We want this timeline to start from the beginning after the tile turns red. After testing it out, you can clearly see that it looks a lot better and the player still falls through after it shrinks. I do think it's a bit quick to start shrinking, so I'm just going to add a small delay before it shrinks to make it shrink slower. Also, instead of taking 1 second to shrink, I'm going to make it take only 0.6 seconds, so there's a bit more of a delay before it shrinks, but once it starts shrinking, it shrinks a bit quicker, and the timeline should also end after 0.6 seconds too. Trying this out, it feels a lot better to play. It's basically finished now. If you want, you can remove the floor and the walls so that the player can fall down at the end. I hope you enjoyed making this small level. Make sure to like the video if you enjoyed, and please follow my channel if you want to see more videos like this one.